Hello all, welcome to part 4 of the Windows Assembly Language for Hackers video series. In this video, we will understand how to define data types using the MASM assembler. So here are a list of data types, their size in bytes and their values in ranges. I mentioned a couple of the range values, others I've just left it as an exercise to you. So we have byte, which is 1 byte. Then you have S byte, which is a signed byte, which is also of size 1. Then you have word, size 2, S word, D word, SD word, F word, Q word, and T byte. Data initialization. You can initialize data by giving it a label, then mentioning the data type, and then the initialized value. In this case, integer byte 16 defines a byte containing a value 16 in it. In this case, signed exp S word 4 into 3 has gone ahead and defined the signed word containing a value 12. Now if you do not want to initialize a variable, you can go ahead and give question mark, which would actually mean that it is uninitialized, right? Now here's one of the interesting applications. The requirement in MASM, of course, is that whenever you use instructions like move, etc., then the source and destination should be of same size. Now to accommodate that, there is a directive which we can use called PTR. So let's say you want to move 1 byte into the AL register from a D word called demo, which has a value 10 in it. So what you can do is you can say byte PTR demo, and what this does is interprets demo as a byte and moves that into AL. Now let's say you want to move a word or 2 bytes into the AX register. You could write move AX word PTR demo. This interprets demo as word and takes the 2 bytes and puts it into AX. Finally, if you want to move the entire D word into EAX, you can just say move EAX demo. Logical instructions and or not XOR, I think most of you are already aware. Just mention it here for the sake of completeness. Arrays. Well, arrays, the most interesting thing is that it is a list of elements having the same data type, and members occupy contiguous memory locations, which means they occupy locations one after the other in memory. As an example, you can define a D word array of 4 numbers 1, 2, 3 and 4. Now one of the other interesting operators is basically the dot operator, which is responsible for duplicating data. Let's say you want to create a byte array containing 10 elements, and all those elements should contain the value 1 in them. You could do that by writing byte array db 10 dupe 1, and what this does is creates 10 bytes all containing the value 1 as shown in this example. Now if you do not want to initialize the data, then you could put a question mark. So data buffer 256 db dupe question mark goes ahead and creates a byte array of size 256 but does not initialize each of its elements. Now one of the interesting things to note about dupe is that whatever you place inside it is going to be duplicated as a sequence. So if you say 10 dupe 10, 20, this will duplicate the pattern 10, 20 10 times. So in this case, we actually have a byte array of 20 elements, and those elements have the value 10, 20, 10, 20, 10, 20, so on and so forth in an alternating fashion. Now, referencing these array elements is a totally different story, and people coming from high-level languages would find it a bit anomalous at times to figure out exactly how this works. Now, the important point to note here is that in assembly, we have to reference by the number of bytes from the start of the array, and there is no notion of traversing the array using the individual element indexes. What do I mean by that? Let's say I define a word array, in this case it's actually a D word array, and have 5 elements in it called 1, 2, 3, 4, 5. Now word array 4 does not mean the 5th element, which is 5. Instead, what it means is that basically start counting 4 bytes from the beginning, and actually this means the start of the element 2. Because it's a D word array, the size is 4 bytes, and hence the number 1 occupies 4 bytes. So word array 4 traverses those 4 bytes and comes to the beginning of the number 2, which is actually the second element in the array index. Small typo here, I mentioned 3. That's wrong. It should be 2. There are other simple operators as well, such as length of, size of, and type. Length of operates on an array and actually gives the total number of elements. So as an example, if we define a word array of size 40, then length of gives the value 40. Size of gives the total value of the array in size. Word occupies 2 bytes, there are 40 elements, hence size of array is 40 into 2, 80 bytes. Type tells you the kind of array. Because it's a word array, each individual element is 2 bytes in size. Declaring and initializing strings. Now, according to the MASM 6.1 assembler programmer's guide, strings cannot be longer than 255 bytes. Right? Initialized strings, of course. Now, byte string definitions can be done in multiple ways. You can actually say hello world DB and write hello world of assembly. But note that because it's a byte array, there is no trailing 0 at the end, because of which the current string is not null terminated. So you will have to explicitly specify null termination by defining DB hello world of assembly, then giving a comma and defining the last byte as a 0. Now the important thing to note is, other than the byte data type, only the first element can be initialized for all other data types. What I mean by that is hello world DW no would definitely work. However, hello world DW YUP yup, which is actually 3 bytes, will not work. Okay, so let's do a simple demo program to understand many of these concepts better. In this demo program, we'll take 2 numbers, add and subtract them, and then show the results. Let's go to our code directory, and the file which we'll right now look at is numbers.asm, which you also have on the same page embedded. Let's open up this file in Vim. Now this whole program can be written in a very simple way. However, just to explain things properly, I have done it the lengthy way. So let me make you understand the program. In the beginning, we have the usual stuff, the includes, the include libraries, etc. Now in the data section, I have defined 2 D words, number 1 and number 2, which will hold the numbers given by the user. Then after that, you have 2 strings which will hold the user input 1 and user input 2. Then we have message 1 and message 2, which prompt the user for entering the first and second number. and then you have the string which will hold the sum of the two numbers and the difference of the two numbers, and a couple of other things I'll just tell you in a second. So the first step is to take user input. Now this can be accomplished by using the stdin library call available with MASM32. So what I've done is I first go ahead and print message 1, which is please enter the first number, then take the first number as input, then send the second message which is please enter the second number, take the second number, I first confirm what the number entered by the user is, then I print the second message which is prompting the user to enter the second number, then I take the second number as input, and then once again print it on the screen to just tell the user that this is what he entered. Now, one of the important things is that there would be a trailing new line character with this input given by the user. Now we will invoke a library called strip lf to go ahead and strip this from the end. Now let's go to the help file masm live. Right? So it's designed to remove the crlf by writing an ASCII 0 in the place of the first occurrence of the ASCII value 13. Now once we do this for both the inputs, note that currently both of them are still strings. So we need to convert these strings to numbers. Now in C programming we would have used something like A to I or A to L. In this case we will again use one of the MASM32 library packages, and this is basically listed under conversions. So we will use the A to DW, which is convert ASCII number to D word. Now the input to that is nothing but the string which was entered by the user, and the output, which will be the number, is stored inside the EAX register. So what we do is first we will invoke A to DW for the first user input, and then store the output which is stored in EAX into number 1. Similarly, we do the same for number 2. Once we get both the numbers in these two memory locations, which is number 1 and number 2, we add both the numbers and then go ahead and store the sum into the num sum memory area which we have defined here. Similarly, we do the subtraction and store it in num sub. Right, this is the place where we do it. Now what we need to do is still the sum and the difference are both numbers, but to print them we need to convert them into strings. So we invoke the reverse functions, which is dword to ASCII. Now once again this has been documented well. Here you can go to the conversion index and dword to ASCII. Right? So what this does is it takes the number you want to convert and the address of the string variable in which you want to store the converted number as string. We invoke both of this for both the sum as well as the difference. Finally, we again call std out to print this on the screen, and then we call exit process. Fairly straightforward, easier way to do this, but I just shown this in a much more easy to understand way. So I tell you to first try this program yourself and then to use this solution if you still cannot do it. Anyway, let's come back here and assemble this program. So we assembled it. Now let's go ahead and link it. We also linked it. Now let's run it. Please enter the first number, which is 20. It gives us the output back 20, whatever we've entered. The second number, let's say 10. And now if you notice, it gave us back 10. Then it says sum of the two numbers is 30 and difference is 10. Can try the other way around also. Give the first number as 10, second number as 20. Sum of the two numbers is 30, difference is minus 10. Right? So works perfectly as desired. Awesome. So well, that's all for this demo. Try this program out, very simple one. You should be able to do by yourself and only then look at this solution. So well, that's all for this demo. In the next video, we will look at how to write procedures which are akin to functions in assembly language. As always, please leave your comments behind because as I mentioned, this is what encourages me to create more and more videos, and it actually makes me feel as if people are watching and appreciating the videos. Okay? Thanks a lot. Have a